Multicollinearity in econometrics refers to a situation in a multiple regression model where two or more predictor variables are highly correlated with each other. This high correlation makes it difficult to isolate the individual effect of each predictor variable on the dependent variable. Instead of measuring the unique impact of each independent variable, the model struggles to differentiate their effects, leading to unreliable and unstable coefficient estimates. Think of it like trying to determine the individual contributions of two cooks to a dish when they always add their ingredients in the exact same proportions. It becomes nearly impossible to say how much saltiness comes from the first cook and how much from the second. Why is multicollinearity a problem? Inflated standard errors. Multicollinearity increases the standard errors of the regression coefficients. Larger standard errors lead to wider confidence intervals, making it harder to reject the null hypothesis and conclude that a predictor variable has a statistically significant effect on the dependent variable. You might fail to identify truly important variables. Unstable coefficient estimates. The estimated coefficients become very sensitive to small changes in the data or the model specification. Adding or removing a variable, or even a few data points, can cause drastic swings in the coefficient values. This makes it difficult to interpret the magnitude and direction of the effect of each predictor. Difficulty in determining individual effects. The primary goal of multiple regression is often to understand how each independent variable influences the dependent variable. Multicollinearity obscures these individual effects because the correlated predictors are essentially sharing the same information. Misleading statistical significance. Due to inflated standard errors, you might conclude that individual predictors are not statistically significant, even if they have a substantial impact on the dependent variable. However, the overall model fit, R-squared, might still be high, leading to a confusing situation where the model seems good overall, but individual variables appear unimportant. How to detect a multicollinearity problem in a regression model with intuition. Here are some common methods to detect multicollinearity, explained intuitively. 1. High pairwise correlations. Intuition. If two or more independent variables move together very closely, they are likely measuring similar underlying information. A high correlation coefficient, close to +1 or -1, between a pair of independent variables suggests potential multicollinearity. How to check? Examine the correlation matrix of all independent variables. Look for correlation coefficients with absolute values above a certain threshold, e.g. 0.8 or 0.9. Caveat: low pairwise correlations do not guarantee the absence of multicollinearity. It's possible to have multicollinearity involving more than two variables. 2. Variance inflation factor (VIF) intuition. The VIF for a particular independent variable measures how much the variance of its estimated regression coefficient is inflated by the presence of correlation with other independent variables. A high VIF indicates that this predictor can be well predicted by the other predictors, suggesting redundancy. How to calculate? For each independent variable, regress it on all other independent variables in the model and obtain the R-squared, R_I², from this auxiliary regression. The VIF for that variable is then calculated as interpretation. A VIF of 1 indicates no multicollinearity. A VIF between 1 and 5 suggests moderate multicollinearity. A VIF above 5 or 10 is often considered to indicate high and problematic multicollinearity. 3. High R-squared with insignificant t-statistics. Intuition. If your overall regression model explains a large portion of the variation in the dependent variable, high R-squared and a significant f-statistic, but the individual t-tests for the coefficients of the independent variables are mostly insignificant, low t-values and high p-values, this could be a sign of multicollinearity. The correlated predictors are jointly explaining the dependent variable, but their individual contributions cannot be precisely estimated. How to check? Examine the summary output of your regression model. Look for a significant overall f-statistic and a high R-squared, coupled with insignificant t-statistics for many of the predictor variables. 4. Auxiliary regressions. Intuition. As used in the VIF calculation, if you can predict one independent variable well using the others, they are likely correlated. How to check? Run regressions where each independent variable is treated as the dependent variable and the remaining independent variables are the predictors. If the R-squared values from these auxiliary regressions are high, it indicates high correlation and potential multicollinearity. 5. Tolerance. Intuition. Tolerance is simply the inverse of the VIF tolerance_I equals 1/VIF_I. It represents the proportion of the variance of an independent variable that is not explained by the other independent variables. Interpretation. A low tolerance value, typically below 0.1 or 0.2, corresponds to a high VIF and suggests a high degree of multicollinearity. By using a combination of these methods, you can get a good sense of whether multicollinearity is a problem in your regression model and take appropriate steps to address it. Remember that there is no single definitive test, and often a combination of indicators will provide the clearest picture.